Okay, welcome back. Hope you can hear me fine. If you can hear me, just type in the chat. That would be handy. For some reason, oh, there we go. Okay, so it's all started. That's all good. This help session, I'm going to cover header files to start off with. Header files won't take too long, and then I'm going to cover the assignment, and if we have time, we'll talk about the exam or anything else you'd like to talk about. So I'm going to cover the assignment. I'm not going to give too much away because yes, ideally you are working on stage 2 by now. So stage 1 should be done. Stage 1 is practically the same as the last assignment. There's nothing new in stage 1, and anything new, like RAND, I've given you the code. So stage 1, we aren't really testing any new knowledge, so it's not worth much. Compared to the other stages. Okay, because it's fairly easy. It's nothing new, and yeah. All right. So let's have a look. So one thing that some people forgot is the standard lib library. Don't forget it. You've got your function prototypes. Okay. Now, one thing you need to remember is when looking at these function prototypes, you have to look at these stars and realize that, okay, this get move function, for example, I know these here, these first 3, are going to pass an address in or a pointer, which holds an address. Okay? And I know these 2 I won't. So when you see a star, you need to remember that there's going to be a pointer passed. And don't just guess and chuck a million M's and W's and random stuff until it works. All right. Implement the first 3 functions from above. So initialize my bullets, initialize my values, and make move. So they should all be done by now. You've got 2 structs. You've got the location and the game. So we might have a look at this location and game just to understand Minesweeper a little better. Now, create a global variable. If you call this global or globe variable or something like that, you will lose marks for naming. Okay? I don't call a local variable. I give it a meaningful name. Okay? So make sure that you give this still a meaningful name and don't call it global variable. Because if I was writing code and I had int main local variable, int local variable, what are you going to call everything else? And it's not very useful. Okay? So don't call it global variable, please. That's not what I wanted to do. Now I've lost what I was doing. Okay. Define a macro. Name mine as value 0, flag as value 1, and revealed as value 2. Everyone's done this pretty well. Don't forget, do not put a semicolon after the value. Okay? And these are to be used as bit flags for the status byte. Okay? So let's have a look at that. Now this is something you've already done before, but without macros. So I'll copy this across. Okay. So this part here, now obviously we're not doing it at this stage, but is exactly the same as on the bit lock thing, except for we're using macros. So we've got mine defined as 0. I'm not giving you how to do that, but you can work that out. We've got flag as a 1, and so on. You've got a status byte, okay, which will be a car. And this basically has 8 bits, okay, because it's a byte, or a car, which is a byte. Now, we're only using 3 of these flags, so these top ones we don't really care about, okay? However, initially we set them to 0, but we never really care. It wouldn't really make a difference if they were 1s. The bottom 3 we do care about. So the 0th flag, which is mine, if it's a 0, then it indicates that there's no mine. If it's a 1, it indicates that there's a mine. The 1th flag indicates if there's a flag there, a 0 if it doesn't, and this one will indicate if it's revealed. Okay? So for each location, there is a pointer to that location, and that information includes a status byte and something else. I can't remember what else. Oh, it's value, sorry, and it's value. Okay, and so while we're playing the game, if this is a 0, then you can't see anything under here. And when this becomes a 1, then you can see the value, let's say a 6. Okay, so the value is a 6. All right, but while it's a 0, it's hidden or unrevealed. Okay, so how we change this is pretty much like in that bitwise lab. We can do set, clear, toggle, and we can also do test. Okay, so if I want to set this first bit, the mine bit, if we remember, we can just go status byte or 1 shifted mine. Okay, and that'll set this 0 bit. Okay, so you've got all these on that lab. So you can do testing, you can toggle, you can clear, you can set, and you can do as much as you like. Okay, does that make sense? So you've got all that information already. If you're here, please say something, see if it makes sense or not, or doesn't. Just say yes, thank you, or no, it doesn't, whatever. Because I know there's quite a few people here. Okay. So just refer back to that lab where we did the bit lock, and you can do exactly the same things with this status byte. All right. All right. Let me grab the lab back up. If is it? There it is. All right. Now, it might seem funny, it might seem stupid, but I am going to emphasize this point. This needs to be done in this format. There is no spaces, there are no tabs. This is the start of the line. Now, someone has actually written this. This is your name. Okay, and this is your student number. Okay, please don't write John Smith. All right. And that comment shouldn't be there. But you can ignore that. Right? If you put John Smith there, you won't get your marks. All right. We all know how to create a struct now. Now, one big thing, that is a type. If I see these two words separated anywhere, then I won't be happy. Okay? Yes, it's funny. I was not laughing. Well, I'm probably laughing a little bit, but I wasn't laughing after that. Just created more work. Okay, so please don't. Okay, with your structs, once you've got your variable, you do not need to use the name of that variable anymore. I mean the type again. Okay, just use game. Right, struct game has already been used. It's when it's declared. It's the same with int a. We don't write int a after that again. Okay. Go back to the struct lab if you want to review it, or go to the struct lectures. Set both the mines flags and flags variables in the game struct to 0. So we know how to do that. Game dot flags. So I had a good question, and that is, if I add a title, will you lose marks? So possibly. So part of this, and the reason the assignment is set up like this, is not only testing your ability to code, it's also your ability to follow a standard. So if I've requested a particular format, then you don't know what it's used for. If your client requests something in a particular format, you should never ever go outside of that standard. So adding titles or funny jokes or extra things always get picked up because they don't follow our script, and you don't know what we're using your code for. And this is a perfect example. Your code runs through a script, and so it breaks the script. And so because you went against the standard, it doesn't work as intended. Okay, and you're unable, we're unable to use it. And if this was a real world piece of equipment, this could be dangerous. Okay, and it's something that happens a lot in the real world, because people want to show off their skills rather than follow the specs. So you shouldn't add things like titles and things like that unless it says be creative, or we want you to design something that's creative. If they give you a specific spec of what's to be printed, there is a reason for it. And you'll notice that we are being very specific about the spec. So even when we do give you options, it has to be one line, ending in a new line, and you can choose an appropriate message. Okay? But this needs to be to spec. All right? So unless it says add a title, don't. Okay? Because you're just breaking the specification. And this does happen in all kinds of fields, not just programming. Okay, all types of engineering, all types of computer science. the client wants that, they will ask. All right. So don't forget your dot operator. I'm pretty sure flags isn't a pointer. Okay. No. So dot flags becomes 0 or 1 or 10 or whatever. Don't write struct, don't write game here. They're not the same thing. All right. Ask the user for the width and the height of the board. If you don't know how to do this by this stage, I can't help you. Ask the user for the number of mines and store in the game variable appropriately. Now, when I say all this is something that you want to debug, okay? Make sure it actually works. It's very simple, it's easy to debug. Make sure it works before you go on. Because if this doesn't work, then nothing else is going to work. Same with these two lines. If step 6, which is a lot harder, isn't working, and you've got something wrong with 4, you'll never know because you didn't debug it. All right? So debug these early steps so that some of the hardest steps aren't impossible because they can't work. Right. Step 6. Create a pointer to a pointer. So a pointer to a pointer is a double star. A pointer to a pointer to an int. Okay? So it's a double pointer. All right? This here is saying a double pointer. But double pointer doesn't really make any sense because what's double about it? It's a pointer to a struct. Location, name mine board. Okay? And dynamically allocate the memory of size, game, height, blah, blah, blah. So we get a big array of pointers. And then we get a whole heap of, where's the rest? I need to copy it, sorry. That would help quite a lot. The explanation for on this is that 10-minute video as well. Okay. And then iterate across these pointers. So you should have size of game height 2, so a bunch of these pointers. Size of height +2. And then each one of these is going to point at one of these. And we did this in the last assignment. So you just end up with a bunch of arrays and arrays and arrays. Okay, and then you can just use square brackets to go. This one is referring to this, and this one is referring to this. And so you can get to anywhere in your table. Okay. Are we happy up to that stage? Step 8 and 9, function calls. Okay. Initializes the board using the appropriate function. Okay. So why we're plusing 2 actually comes into, so why are we adding 2 is actually a good question. And we'll see this in a second, but our board actually looks like this. Okay. And the game that we see is in here. Okay. Now, when we get to step 3, stage 3, having this outer border helps a lot with the recursion. Okay, so in the first couple of stages, you won't really see the purpose for the +2 because you'll only see the game inside here and you'll ignore all of these spots outside. But your game board has this hidden border, okay? And we'll talk about this hidden border in a second when we talk about initializing the board. So let's go. So obviously this is initialize board and this is print function. So let's grab this initialize board. Make sure you draw. Why do I keep doing that? I did that on the last thing I made. Drew a big line across it. Make sure you draw a box and pointer diagram when you do a function call because a lot of people are still doing function calls very wrong. All right. So create some iteration variables, blah, blah, blah. Iterate from 0 to gain height +1 inclusive. Okay. So we're going from the 0th all the way to game height +1, which is down here. Okay. We are then going from 0 to game width +1. Okay, so this is our board. Okay. Because normally when iterating over a two-dimensional array, we'd be going, well, knowing what we know about arrays, if I had an array of n, to iterate it, I go from 0 to n minus 1. But because it's +2, we go from 0 to game width +1. Okay, because we have 0 to n +2 minus 1. All right. Does that make sense? Why we go from 0 to game width +1? Because we have this hidden border with added 2. Okay. Set status byte for 0 for every location. Okay, so we're iterating over our array, so this thing, which we can imagine looks like this. Okay, so we don't have to think of it as this ugly pointer thing. Because we've got these square brackets, we can just treat it like it's this. Okay. Now, you'll notice that the y is first and the x is second. Okay. The reason is because the width are the rows. Okay, and that's done second. Okay. So the x goes across, and so the x, it's not xy, it's yx when we refer to the array. And I did give you that in 5b just to make sure that you weren't doing it backwards. All right. So if I wanted to refer to location 1, 1, oh, sorry. That's a really bad example. If I want to refer to, let's say, 2, 1, where this is x and this is y, then this would be location 1, 2. And because we're talking about x, we go across to 2 and down to 1. So we're talking about here. However, when the user's using this game, they don't consider this 0. But we notice that it doesn't matter because our game board, so this part in here, starts from 1. So we don't need to do any conversion. So that's also another advantage of having the board like this, is that we can start it with a natural 1. So we set the status byte to 0 for each of the locations, which makes sense because, I don't know where I put that stuff before, because none of them are flagged at this stage. none of them. What were the flags that we had? We had flags, we had revealed, and it was mine. So none of them are mine, none of them are flags, none of them are revealed at this stage. So we just set every single one to 0. Okay. Be happy with that. All right. Yeah, it's all good. Cool. Create a couple of variables and initialize the game lines. Okay, create variables x and y. So this rand function will just generate a random number, and this modular this mod operator will basically, so if we have, let's say rand here, and I go mod 10, this ensures that all the numbers will be from 0 to 9, purely because this is the remainder function. Okay? So if this comes out as a 9, I get a 9. If this comes out as, let's say, a 330 at 9, then I get a 9. If this comes out as 1,309, I get a 9. So it always gives me a number between 0 and 9. So adding this mod, or remainder function, allows me to limit my rand from between 0 and something. Now, if you want negative numbers, you need to do a little bit more there, but we don't need negative numbers. So we want a number from rand to game height plus 1. So we're basically saying that we want numbers between here, because we're adding 1, and here, and here, and here. So you can see we're not touching this border region. We're only playing in the game field. And we keep iterating. So we can see this is a loop. And we basically, let's say rand gives us 4, 3. Okay, so y is 4 and x is 3. So we test, we go to y 0, 1, 2, 3, 4. And we go x3, so 0, 1, 2, 3, so we end up here. Okay, and we test, is this a mine? Using this line here. So mine board, and we're just doing a test, and we're just saying not a mine. And if it is, then we just set the mine bit, okay, and decrement temp mines by 1. So just go temp mines minus minus or something like that. Now, this is what we talked about before, all right, when we talked about bitwise stuff. And then call the initialize mine values function. So that's fairly self-explanatory. It basically gives you the answer. Are we all happy with that? Please. it up to that stage. Okay, I'm going to have a quick break. Talk for another hour, and then we'll go over the next function, and then we'll start looking at stage 2. So I'll be right back. I won't be very long. Just need to stop talking for a second. All right, I'm back. So let's do this. We have to. Let's close this. All right. Where it will be in a lecture theatre. I'm just confirming all that at the moment. So sorry, I probably should keep this for the recording. So I'm organising a bunch of mock exams. The exam will be very similar to the real exam, so you do not want to miss it. Basically, you'll get the same amount of time, so the exam conditions for 2 hours, and you will do an exam. Then you'll have a half an hour break, and then we'll have 2 hours to go over the answers. And there'll be 3 sessions, and you can kind of attempt. What I recommend you do is you come to at least 2 sessions. So you do the first session, and you get like 10% or 20%, or hopefully more than that, but and then do the next session and do better the second time. No, it's not, because we're using it for the mock exam. So you need to come, because you'll get a copy of it. Yes, that's during swap back. Last year's is not on LMS. It shouldn't be. No, it's not. The ones that are up on LMS are very different from this year's and last year's exam. Okay, but they are very helpful as well. Okay. However, you need to be aware that they may include content that's not included in the subject anymore. Okay. All right, let's continue. Where were we? I don't know if we can record it. I'll have to find out about Echo. I doubt it, because it's not part of the timetable, but we'll see what we can do. We can bring a phone in or something to record it. How does that come up so small? That's crap. So the ones on LMS aren't similar, but the one we'll do in the practice will be very similar. It's pretty much the questions will be very similar, and there's slight variations. There's major variations, but the format will be pretty much the same. And there's things like box and pointer diagrams and stuff that's not on the previous year's exam. All right, so where's my pen? All right, so now we need to initialize the mine values. So I might just get a simple, it's going to be, hopefully, let me check my email. I did send it off to request it. What did I say? I said, now this is, if I can't get the room, then this won't be it. But I asked for the 30th, the 31st, and the 1st from 10 AM to 3 PM. Okay. It won't be 5 hours. We need half an hour to set up and stuff like that. But yeah, it'll probably be 10:30 to 3 PM with a half an hour break in between. Okay. And that's Tuesday, Wednesday, Thursday. But as I said, that depends on the room, so these dates might change. All right. So I've got some back here, let me get rid of. So now let's have a look at this stage. So I'm going to draw my line board up again. I'm just going to do a simpler one. So this is a 4x4. Okay. And as you can see, it is a 4 by 4, but we've got the +2. So the width and height is a 4 by 4. So the user entered a 4 by 4, and we're going to iterate from 0 to gain height +1, gain width +1, and 0 to gain height +1. So we're going to go over the whole board. If I, okay, so I is talking about the height one. Okay, that's I. This is J. Let me be on a higher layout. And this is J. So if I is equal to 0 or equal to gain height +1, or J is equal to 0 or J is equal to gain width +1, then set the value of the ij coordinate in the mind board to 0. So we've got this dot value. Well, it may not be a dot depending if it's a pointer or not. Actually, it is a dot, so it doesn't matter. To 0, which we can see is right there. Okay. It's not a pointer, so we don't have to worry about that. So we're basically just setting all the ones that surround as zeros. And this is purely for stage 3 that we need to do this. It doesn't help you with the other stages because you don't really care about this at this stage. Okay, so we're just setting all of them as zeros every time. And we set the revealed bit to 1. So these are, all the revealed bits for these are a 1. Okay, so these are revealed. And we saw how to do this for a mine, so we should be able to do this for the revealed as well. And we also have all these, and some of these will have their mine bits set. So let's say these 3 have their mine bits set. Okay, so it's a 4 by 4 with 3 mines. Okay. Else, create a variable named count. Count the number of mines by checking the mine bit of all locations that surround I and J. So if we are here, then we can check this one, 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 and this one. Now, you don't actually need ifs here if you do it correctly, but if you want, you can use ifs. If you're good with your bitwise operations, you can actually do this in very few steps. Else you can just use ifs. But if we're here, I is currently 1 and J is currently 1. So this location here is I -1, J -1. Okay. This one here is I -1 and J. This one here is I -1, J +1. This one here is I, J -1. This position here is I +1, J -1. This one here is I +1, J. This one here is I +1, J +1. And then this position here is I, J +1. Okay, and that'll give you all 8 surrounding pieces. Okay, so they're the 9 checks that you need to do. So if we check all, not 9, 8, sorry, they're all the 8 checks we need to do. So if we check all of these, we check this one first, we get a 0. We check this one, we add 0 to that, so we get 0. We check this one, we add 0 to that, so we get 0. We check this one, we add 0 to that, so we still get 0. We check this one, we add 0 to that. We check this one, we add 0 to that. We check this one, we add 0 to that. And we check this one, it has a mine bid set, so we add 1. We add all these together, and we get a 1. So this location now has a 1. So we keep going, and we do this to all of them. So this one would come out as a 1 as well. This one would come out as a 1 as well. This one would come out as a 0. This one would come out as a 1. And then we get to this one. So we'll do an example of this one again. So here, we check all the ones that surround. We also check the one with the mine. So this would be a 1 because it doesn't include itself. Okay. You don't actually have to check this one, but in this code we are. So it does have a value, but it has a value of 1. So just be aware of that. So now I go around. This doesn't have a mine, this doesn't have a mine, this doesn't have a mine. This does, this doesn't, and this does. So this would have a value of 2. This one has a value of 1, 1, 2, 2, 2, 0, 1, and a 2, and a 1, okay? Because it doesn't count itself. All right? And that's basically all we're doing in that initialize my values function. Okay? Come on, load already. Load. Does that make sense? Say yes or no. Say yes, please. Thank you. Whatever. Okay. Now, you can use ifs, but as I said, there is, because these are all just bitwise operations, and these have a 1 inside them, you can just use bitwise operations. You do not need to use if statements to do this. All right. Okay. And that's pretty much stage 1 done. So that's pretty fun. Okay, and there's nothing too difficult there. Now stage 2 is where the fun starts. So what a lot of people fail to do, and this is why it's highlighted, so once you've got stage 1 working, make a copy, okay? Because you can always go back to a state in which your program works, okay? So do not forget that, okay? Make sure you save a copy. And if you want to submit multiple, I don't mind, okay? Then declare variables for flag, X location, and Y location as appropriate types. So flag is purely going to be a 1 or a 0. So you can choose an appropriate type for that, not a Boolean type. The x location is an index and the y location is an index. So it's only going to store 0 to game height. Well, it's not even going to store 0 because we don't want 0, but it's going to hold 1 to game height, and y is going to hold 1 to game width. So you can choose an appropriate type. Could y location be 1.1? I don't think so. Okay, so you can choose the appropriate type. And then follow the flow diagram to write the next segment of code. I accidentally got that out. Okay, so now we get the flow diagram. And this is a bit of logic. Okay, so we have a big flow diagram. I'm going to grab the bottom of that. And up here is just step 12, I think, or step 11, yeah. So that's step 11. Okay, so if you go on LMS somewhere, what's LMS? There we go. You go to LMS and you go to week 7. We can see all of the things for a flow diagram. So we've got the symbols for a flow diagram. If this loads. Okay, so we've got all the basic symbols. One that a lot of people miss is, come on, hurry up. Why are you being so slow? Is the do while loop. Okay, so you notice that there's that little dot there. And we get that do while happening. Okay. So if we have a look at this, we have a bunch of conditions and we can break this down, okay? And this is how you should handle big flow diagrams. So we can see that this here, oh my God, what's going on? Okay, we can see here that all of this down here pretty much leads back up to here. Okay? And it goes through a bunch of stuff. But we can see that all of this whoops, I'm going to name that. I want a little bit more of that. We can see this is just a big loop around this. So I've actually got this, some code that comes back up. Okay, so we can see that that is some kind of while loop. Okay, if we have a look at the while loop flow diagram, it's a do while, we don't want that. Come on, hurry up. while loop. We can see that a while loop is basically just a condition, some code comes back, yes or no. Okay, and we've got the same thing here. Yes or no, and some code in here. Okay, so we can see that all of this is inside a big while loop. We can then also see here that this happens, we do some code, we check some condition, and we go back up. So we have a do while loop here. Okay. We can see that this and this never come back to themselves. So what is that type of condition called? Anyone in the chat? Chat. Ah. That is a good point. So I don't actually tell you what a live is. I might actually fix that up. Yeah, so this is an if. So these are just if statements. Okay, I'll come back to the alive. Alive is based. Actually, I'll come back to it. This looks like an if. This looks like an if, and these just look like statements. Okay. So the flow diagram is not as complex as it may first seem. Always try and find the loops first. Now, alive is the global variable. Okay. Because basically that's what that global variable is doing. I didn't make that clear, so I might add that on the elements. Okay. However, you should be able to work it out. There's already someone that's finished. Well, actually, there's two people that have already finished the assignment, and they were able to work it out. So I think it shouldn't be too hard to work that out. Well, I will add it as a note. Okay. But that is the global variable, because that's what the global variable does. What do you mean, what? No. It's not about not having a life. It's that they're students that are stronger. And we have to cater to all of them. We don't want this subject to be boring. Yeah, people are finished. It's not an overly difficult assignment once you've understood the content. So, no, they're not master students, they're both undergraduate. All right. So, where are we now? Ah, it's not hacks. Yeah, pretty much. The assignment should take, this assignment should take, if you know what you're doing, maybe 3 hours. If you're learning at the same time, maybe 6 to 8 hours. And if you're very good, maybe an hour or two. And if the biggest thing is that the biggest mistake that most students make with these assignments is that they're not debugging themselves on the way through. And so they're the hacks that just try and hack it until it works. If you're debugging as you go through and you know what you're doing and you're not just following the steps, rather you're trying to understand it, you can get this assignment done fairly quickly. Okay. All right. So then we check the alive variable, which is the global variable. Oh my God, why does it keep happening? See if the user's won, you can print an appropriate message. Don't refer to the bonus, it's not a bonus anymore. Okay. It used to be last year, but it's not anymore. And then end the function correctly. I don't know why I gave you a hint there, I shouldn't have. I'm too nice. Way too nice. All right. So what else do we need to do? Make move and get move functions. So make move. Actually, you're probably better off with get move first. I'll put it here anyways. I'll get move as well. Okay, get the function that gets a move from the player that takes a pointer to the x coordinate, y coordinate, and flag. So you're talking about passing it by reference here. The max x coordinate and the max y coordinate. Okay, so where the hell did my pen go? Sorry. There it is. Sorry. All right. So the max x and max y are kind of important. Remember that the max x is here. I mean, yeah, max x is here, max y is here. You've got this extra spot, but that's you can't access, the user can't access. So the max x, the max y is here. The min is always going to be 1, okay? And 1, okay? Is the minimum. This is the minimum, this is the maximum, this is the maximum, this is the maximum. So you can't go outside of that border. As we said, the game is inside of that boundary. Ask the user for X, Y, and flag. You've done this in lab 2. Store the location pointed to by the pointers appropriately. Yeah, just dereferencing. Continue asking the user if the locations are invalid. So if we had a 4x4 and the user enters 1003, you just keep asking them, because obviously you can't get location 1003. Okay, or if the flag is 8. Okay, so that's really easy. And then you got the make move. So this function takes the game information, the board information. Does that make sense? The get move function. There's nothing new in that. It's basically lab 5 and or less. Happy with that? All right. Make move. So this function takes the game information, the board information, the location of the coordinate to be revealed. It tests if the coordinate is a mine or not. And if it is, it sets the appropriate variable, which is alive, obviously. So we've got our game board. We've got our play area, which is this. So some of the positions might have mines. If the coordinate has a mine, so if they entered 1, 1, set the appropriate bit to revealed. So make that revealed as well, and set that alive variable to 1. Else, set the appropriate bit to reveal the given coordinate. So if they entered, let's say, 2, 2 instead, this doesn't have a mine, so we set it to revealed. It will then show the number. So this, in this case, it would show a 2. If it's a flag, then we don't show. So if they enter a flag, then we don't set the reveal. We set this to flag. Why does that say? That's not quite well written. I'm going to fix that because that's not quite right. So if it's a flag, oh no, that is right. That is right. That is right. Sorry. If it's a flag, we handle that in main. So that is right. I just confused myself. So if it's a flag, we unset the flag bit. So if it was a flag, this is not a flag anymore. And then we change it to revealed. However, I've made a change, so this can actually never happen. But you still need to do it. Okay? It just protects the code. And if the value of the coordinate is a 0, so this one, then you call the function uncover zeros. Okay. So this is only a couple of lines of code. And that's pretty much stage 2 done. Stage 2 isn't very long. Okay. It's a little bit of following that. Some really just getting a bunch of scanfs, and then just basically changing some bitwise stuff. And then we have stage 3. Now, I'm not going to give you much information about this, but I might have a quick break before I get to that. My mouth is dry. And then we'll talk about the last stage. And then that's the assignment done. All right, we all still here. Just play if you are. What is one-time solution to crashing? Write your code correctly. It's always the best solution to crashing. Actually, the best way to avoid crashing is just safety. So if you write very safe code, so if you guard against, so generally most people crash because they go outside of an array. So if you always check that you don't go outside of an array, and you may have some macro to check that, you shouldn't crash. Okay, usually that's where most people will crash their code. Assignment. Okay. So stage 3, uncover zeros. All right. You meant browser? I don't know. Just, I don't know. Turn off all your plugins. That's one solution, maybe. All right, function, uncover zeros. So, there is a couple of challenges here, but it is not very long. You can do this in about 10 to 30 lines. That pretty much means you get 1% per line nearly. This is worth quite a lot, okay? And this is testing your logic skills, your ability to engineer a solution. Because in this subject, we don't just want people that can follow orders, but people that can design solutions to problems. So this is worth quite a lot, and you can't get over 90% without doing it. So you should have a good crack at it. It is not very long. It's only a couple of lines. So you also don't need the size of the board. Okay. Now I've already given you a clue here in the fact that we use the fact that we've got these zeros that are revealed around the board to deal with this case. Okay. So if you find a 0, then any 0 that is next to it also gets revealed. Okay? So you uncover all the surrounding zeros. If this 0, if any of these zeros have a 0 next to it, you also reveal that. If this has a 0 next to it, you also reveal that. If this one has a 0 next to it, you also reveal that. So this is basically finding all the zeros. Okay, now that are touching each other. Now, we can go diagonal in our case. In the normal game, you can't, but I don't mind if you do either. As long as it works, I don't mind. If you decide to block out the diagonals, that's fine as well. So you can do this either recursively, which we've seen in the past, meaning you have a function that calls itself. Now you need to make sure this stops somehow. Okay, so you saw in one of the help sessions, and you can read about recursion. When we did, what did we do? Did we do? We did an example using, I don't remember. Can't remember. But we did a recursion example. And if you don't want to use recursion, you can do it iteratively. However, it is slightly harder doing it iteratively. Okay, but it may be easier conceptually, but it is a lot harder to get everything. Okay, and that's basically all this function does. Yeah, we did it ages ago. It's nothing special. Okay, and that's the uncover zeros function. Okay, and then if you do that, you can do the bonuses. Okay, so that's the assignment. So the first two stages don't include much that's new. They're kind of, yeah, fairly low in the terms of the weeks. It doesn't have files or anything like that, so it's not too difficult. But if you do the bonuses, it does. So let's get the bonuses up. So we've got three bonuses. We've got accept input from the command line and write to file. So we've done this before. You need to create a macro named bonus1, and then if bonus1 is defined, the assignment should do this. So this is kind of like how you were using the debug macro. Okay. So accept a file name, which is a string, passed via the command line. The program should check if there's two arguments. We did this last week. Everything that the user enters in the program is written to a file, and then handle the file appropriately, so like close it and all that kind of stuff. And you should end up, the file should like the test cases. It shouldn't like the test cases. It should look like the test cases. I don't care if it likes them or not. So if you have a look at the test cases, I'm going to open that on the screen. So we got a test case on. Actually, why can't I open that in the browser? No, it's not going to let me. I can open it with. Anyways, I'll get that up in a sec. Let's have a look. Okay. This should look. So it should look something like this. Okay, so it has the width, the height, the number of lines, and then all the moves that the player made. Okay, so if you did it right, it should look something like the test cases. Then bonus 2, anti-CSI codes, overwrite screen. So this is a bit of a more of a research task. So read the Wikipedia article. So we go to Wikipedia and we read all this, which is all really cool and fun stuff. Okay, we can learn about. So the main parts are going to be sequence elements. We don't care about non-CSI, we care about CSI codes, and then all this. Okay. All right. And so basically what you want to do is clear the screen and overwrite the screen. Okay, so you're moving the cursor on the screen so that you end up not going down the screen like you are now. And the last one is adding color, which isn't too difficult if you can do the one before. And you're just basically creating these colors for all the flags and numbers and all that kind of stuff. Okay, and that's the bonuses, and there's 6 marks there. And that's assignment 3. What do we think? We're all going to kill it now. Do it slowly. Do it using a piece of paper. Use your box and pointer diagrams. Use your debugger. Debug as you go using a debug macro. You should be fine. If you're just rushing into it and guessing, that's the biggest problem, and that is what slows people down. Okay, if you take it slowly, you should be able to do it quite easily. If you just rush into it and guess and just chuck a whole bunch of ends and stars and loops and random stuff, which I see so many of, you're just going to fight until it works. And if you fight until it works, you're just wasting time. Use your debug macro, hash define, debug as I showed you. Use GDB. Use your box and pointer diagrams. You don't need fancy looking diagrams. You can just do quick sketches of your diagrams. Use your flow diagrams as well. Draw your own flow diagrams. Make sure things make sense. Right?